Welcome back to Canadian Competitive Math. In the previous question, we discussed about similar triangles, and we use properties of similar triangles to develop or to calculate area of a trapezoid. In this question, we are looking at two circles, and this question is again related to geometry, but it's a different kind of geometric properties we are going to use here. So here we have two semicircles with radius 2 units or 2 centimeters, and they're touching each other at this point, and the diameters AB and CD are parallel. AB and CD is parallel, and he's asking what is AD square, right? A is the left bottom corner where this circle is touching this parallel line. D is the top right corner where the other circle is touching the top parallel line, right? So now let's try to establish calculate AD square from this, AD square based on this. So I will draw this, try to just make it more clear. So we have the top parallel line, bottom parallel line, top parallel line here, and we have top circle, and we have bottom circle. Right, this center. Okay, so the diagram says that as per the question, these two circles are touching each other, let us say, and now he's asking us to calculate what this length is, AD square. AD, right? So we know that this is 2, this is 2, we know that this is 2, this is 2, and since these two are parallel, if I draw a perpendicular line to this, and let us call this E, so this DE is 2. So again, this is a perpendicular triangle, this is a 90-degree triangle. So if I know the length of AE, since I already know length of DE, I'll be able to calculate length of AD. So AD square will be equals to ED square plus AE square. I already know what ED is. ED is 2 square plus AE square. So AE square plus 4. Right. Now let us calculate what AE is. Right. So AE, if I draw a line perpendicular here, this will be touching it at 90 degrees. Again, this is like one of the geometric property here. So since this is 2, this part will be 2, right? And we have this as 2, and I'll draw one more line here. This will be perpendicular to this, right? So I have, since this is also it's a radius, this will be 2 here. This will be 2. And now let us call this as C1, call this as C2 dash, right? So we need to calculate what is C1 C2 dash as, and since these two circles are touching here, let us say this is the touching point. If we draw a line connecting both the center, it has to pass through this. And since these two are like, this point is on this circle, this point is on this circle, the line connecting both of them will be 4 units. And we already know that this is 2 units. Say, now if I draw this triangle here, C1, C2 dash 2, and I have this as 4, this length will be equal to this length will be equal to this length C1 C2 dash will be equal to square root of 16 minus 2, which will be equal to 16 minus 4, which will be 12, which is equal to 2 root 3. Right. So now we have to know this. So from this we know that AD square is A square plus 4, and AE we can write it as AC1 plus C1 C2 plus C1 C2 dash, actually C1 C2 dash plus C2 dash E. This will be equal to 2 plus 2 root 3 plus 2. So this will be equal to 4 plus 2 root 3. Right. So that is A square. So we need to square this plus 4, square this plus 4 plus 1. This will be equal to 16 plus 16 root 3 plus 12 plus 4. It's 28 plus 4, 32 plus 16 times root 3. So the answer is B.